Hello dear students, a very good afternoon to all of you. In previous lecture, we have studied about the mechanism of action of mechanism of enzyme action that we have completed in previous lecture. In mechanism of action, we have studied two models. First one was induced fit model, and first one was which model? One second, पेन नहीं चल रहा है. हाँ, so first one was lock and key model, and second one was क्यों नहीं चल रहा है पेन? Second one was induced fit model, sorry. So please remember those things by which we have studied the mechanism of enzyme action. In your examination, questions are always coming on this lock and key model, induced fit model. In MCQ type of questions, they are always asking who proposed this model, who discovered this model, and who discovered this induced fit model, lock and key model. Which scientist names should be remembered there. So let us move to the another part. Now we are ending unit number 1 today. So last part which is remaining is the properties of enzyme. There are several properties, but we have to summarize as far as our syllabus is concerned. So we are going to study today properties of enzymes. So I also have introduced some of the properties in first lecture or second lecture. In first and second lecture, I have introduced some of these properties. So let us go in details of properties of enzymes. It is very easy topic. In examination, question will always come on this properties of enzyme. Whenever question is to be set on first unit, question paper setter is always asking from these properties of enzymes. So this question will come for 3 marks or 4 marks. So you have to concentrate, you have to focus on the topic which is being taught here. So let us start properties of enzymes. So one by one. So first one point coming is catalytic properties. So we are especially dealing here with catalytic properties. So catalyst, you are knowing what is catalyst. Catalyst is a substance which increases the rate of reaction without being consumed. तो catalyst consume नहीं होता है खुद, सिर्फ reaction का rate बढ़ाता है by lowering the activation energy of the reaction. So what are these catalytic properties? Let us see one by one. These enzymes have extraordinary catalytic power. They are having high catalytic power inside the cell. They are active in very small quantity. So we are not requiring kg of enzyme, kilograms of enzyme. We are requiring in only a nanogram, milligrams. very few amount, very small quantity of enzyme is required to proceed a reaction at a faster rate. So these enzymes are required in very small quantities. Remember this. A small quantity of enzyme is enough to convert tremendous amount of substance into product. तो छोटा सा क्वांटिटी में अगर एंजाइम है तो भी काम चल जाता है, रिएक्शन हो जाएगी. They remain unchanged after reaction. So that is the property, catalytic property. No property of enzyme is changed after the reaction. Enzyme is remaining as it is. It is remaining intact. So they remain unchanged after the reaction. One concept is coming here, turnover number. What is turnover number? Let us see what is turnover number. It is the number of substrate molecules, converted, that is converted into product actually. So number of substrate molecules that is converted by 1 molecule of enzyme per second. 1 सेकंड में एक एंजाइम का मॉलिक्यूल कितने सबस्ट्रेट मॉलिक्यूल का कन्वर्जन करता है इनटू प्रोडक्ट, दैट इज नोन एज टर्नओवर नंबर. एंड व्हाट इज फर्दर मोर, व्हेन its active site is saturated with the substrate, that active site of enzyme must be saturated with the substrate. उस वक्त की बात. So remember this, revise this. Let us see once again what is turnover number. It is the number of substrate molecules converted, by 1 molecule of enzyme per second, एक सेकंड में, when enzymes active site is saturated with the substrate. So पूरा के पूरा एंजाइम का एक्टिव साइट सबस्ट्रेट से सैचुरेट होना चाहिए. उस वक्त एक एंजाइम का मॉलिक्यूल कितने सबस्ट्रेट मॉलिक्यूल्स का कन्वर्जन करता है इनटू द प्रोडक्ट, इसको टर्नओवर नंबर कहते हैं. टर्नओवर नंबर, this turnover number of different enzyme is different due to its specificity. Enzymes are specific for that reaction, so turnover number will be specific for that enzyme. It varies from 0.5 to 6 lakh. So it will be less, it will be more, that is depending on the enzyme and type of reaction which is catalyzed. For example, turnover number of lysozyme. Lysozyme, you are in your tears, you are knowing tears falling from eyes. So these tears contain lysozymes and turnover number is very very less. 0.5 is the turnover number for this lysozyme. And that of carbonic anhydrase, which is found in our blood and in plants also. So turnover of this carbonic anhydrase enzyme is 6 lakh. 6 lakh molecules of substrate are converted into product per second. This was all about catalytic properties. So if catalytic properties are asked, you should give this. Next one is specificity. So enzymes are specific. Which types of specificities are there, that we have to study here. So enzymes are highly specific in their action. So enzymes are very very highly specific in their action. So they are catalyzing a specific type of reaction. Not one enzyme is acting as a catalyst in so many reactions. No enzyme is there which is acting as a catalyst in so many reactions. Usually one enzyme catalyzes one reaction usually. Any enzyme is known to act on particular substrate only. So substrate specificity is also there. हर एक एंजाइम का सबस्ट्रेट अलग अलग होता है. So any enzyme is known to act on a particular substrate only. Enzymes are also specific to specific type of reaction. Which type of reaction is there? So that for that reaction enzyme will be specific, because reaction is specific. So enzyme will be specific for that reaction. In some cases specificity is not too much strong. So there are some cases where this specificity of enzyme is not too much strong. There are few examples. Enzymes show different types of specificities. So broadly classified or broadly given specificities are here. Let us see which type of specificities are here. Bond specificity. So enzyme is acting by the bond specificity, so which will require specific type of bonding there, chemical bonding. If that chemical bonding, specific chemical bonding is not present, so there will be no action of enzyme, no function of enzyme. Group specificity. Group specificity means that is functional group specificity. Different type of functional groups are there: aldehyde group, acid group, alcohol. So you are knowing which are the functional groups are there in chemistry. Next is the substrate specificity. Substrate specificity is also there. So for a specific substrate, enzyme is specific. I was telling last time. Stereoscopic specificity, or it is also known as optical specificity. Stereospecific, that is arrangement of molecule in a three-dimensional space, that is also known as optical specificity. Geometric specificity, according to structure, what type of structure is there, molecular structure, molecular formula. So there will be geometric specificity. What is the geometry of molecule of enzyme? Cofactor specificity. So cofactors which are helpful in enzyme action, activity of enzyme, which determine the activity of enzyme. So cofactors are specific for which type of enzyme is there. So at that type of enzyme, cofactor will be specific. So this was all about specificity, how enzymes are specific, in which criteria they are specific. Next property is reversibility. So reversibility, you might have counteracted with that redox reactions in chemistry, reduction oxidation reaction, redox reaction, that is reversible reaction. ऐसा दिखाते ऐसा या फिर ऐसा. So that is sign of reversibility. So enzymes are having reversibility, many enzymes. Most of the enzyme catalyzed reactions are reversible. Many enzyme catalyzed reactions are reversible. There are too many examples. Reversibility of this reaction, or reversibility of enzyme or reaction, it depends on type of reaction, which type of reaction is there, and physiological requirements of the cell, which type of condition, physiological condition in the cell is present. So that will determine the direction of reaction, reversibility of reaction. So if you will take that enzyme action of carbonic anhydrase. Carbonic anhydrase is an enzyme. It also acts reversibly. Carbonic anhydrase which helps in binding of CO2 and H2O and formation of H2CO3, that is carbonic acid. This is carbonic acid. Here enzyme is acting carbonic anhydrase. Same enzyme is acting in reverse direction. So what type of physiological condition is there, that will determine which type of product is formed or reversibility of the reaction. In some cases, there are separate enzymes for forward and reverse reaction. For forward reaction, enzyme will be separate, and reverse reaction, the enzyme will be separate. There are few reactions. Some enzyme catalyzed reactions are not reversible. Some enzyme catalyzed reaction which are requiring enzymes for their proceeding. So many reactions are not reversible. So this was all about reversibility. Next property is sensitivity to heat and temperature. So enzymes are thermolabile. Enzymes are thermolabile, means they are too much sensitive to heat and temperature. Enzymes are thermolabile, that is very sensitive to heat and temperature. A temperature at which enzyme shows maximum activity. जो भी टेम्परेचर है, अगर उस टेम्परेचर को एंजाइम मैक्सिमम एक्टिविटी दिखाता है तो उसको कहते हैं ऑप्टिमम टेम्परेचर. दैट टेम्परेचर इज नोन एज ऑप्टिमम टेम्परेचर. Enzymes are inactive under very low temperature also. If temperature is very low, then also enzyme become inactive. If temperature is too much high, so at that time also they will become inactive. Remember this, because they are thermolabile. They are very sensitive to heat and temperature. At higher temperature, that is this temperature 60 to 70 degrees Celsius, enzymes are denatured or destroyed. Enzymes are destroyed at this temperature. So whenever you get infection and you get fever and other type of symptoms, so doctor says you that keep your water boiled. Boil water which you are being used for drinking purpose. If you are using water, this water for drinking purpose, doctor says please boil this for 10 minutes at least. So at the time of boiling, temperature will goes to 100 degrees Celsius. At that time, bacteria, bacterial enzymes, viral enzymes, what type of, any type of pathogen if there is present, so viral enzymes, bacterial enzymes, pathogenic enzymes will be destroyed from this water, and you will cool this again at normal temperature, and you will drink that water. So here is the reason why doctor suggests to drink that boiled and cooled water. Only few enzymes are thermostable. There are very few enzymes only. The example, there are very few examples of enzymes which are thermostable, which are remaining stable. This enzyme, this is Taq polymerase, which is used in PCR techniques in molecular biology laboratories. So Taq polymerase is the enzyme which is isolated from a bacterium, thermostable bacterium, Thermus aquaticus. Thermus aquaticus, ये जो एंजाइम है ये इस बैक्टीरियम से निकाला गया है, Thermus aquaticus, which is remaining stable below above 70 degrees Celsius. 70 डिग्री सेल्सियस के ऊपर भी ये एंजाइम स्टेबल रहता है, टैक पॉलीमरेज। This was all about sensitivity to heat and temperature. Last point coming is sensitivity to pH. Let us revise the points. Like that of temperature, pH is there. Only thing is coming that pH. pH, you are knowing what is pH. That is negative logarithm to the base 10 of hydrogen ion concentration. That is the pH. So enzymes are very sensitive to pH. They require specific pH for their activity. pH required for an enzyme is specific. Sensitivity to pH depends on which type of pH is required for the reaction. Suppose a reaction requires pH 7, so it will be active, more active at pH 7. If pH decreases, so activity will be decreased. If pH increases, then also activity will be decreased, because that is required in pH 7. For an example I am telling. So sensitivity of to pH, it depends on which type of pH is required for the reaction. So that type of sensitivity it will show. Some enzymes are active, some enzymes are active under acidic pH. For example, pepsin, which is present in our stomach, which is active at this much pH, 1.5 to 2 pH, that is highly acidic pH, highly acidic condition is there in stomach. So pepsin, that is important in digestion of proteins. Then another example given is sucrase, which is important in breakdown of sucrose. You are eating cane sugar, so that is sucrose. So for breakdown of sucrose, this enzyme is required, that is sucrase, and pH required is 6.2, that is not too much acidic. Some enzymes are active under neutral pH, for example urease, urea breakdown. Some are active under basic pH, that is above 7. So example is given trypsin, pH required for this activity of this enzyme is 7.7 to 8. Lipase, breakdown of lipids, so pH required is 8, above 8. The pH at which enzyme show maximum activity, जिस pH को maximum activity दिखता है enzyme का, उसको optimum pH कहते हैं. These are some simple, very simple things are here. Question will definitely come in exam, trust me. Question will come. तो इसके ऊपर क्वेश्चन आएगा ही, यही ध्यान में लेना. येणारच याच्यावरती प्रश्न लक्षात ठेवायचा आणि त्या अनुषंगाने हा टॉपिक करायचा. येतोच प्रश्न, विश्वास ठेवा माझ्यावरती. ज्यावेळेस क्वेश्चन येईल त्यावेळेस मला धन्यवाद म्हणा. मग चलो ठीक है, आज के लिए यही रुकते हैं, आगे दूसरा यूनिट चालू करेंगे हम लोग. थैंक यू वन एंड ऑल. Stay home, stay safe.